Welcome to video 11.1. So today we're going to start off by talking about just some vocabulary, what's on the front of your packet, so that we can go over graphing quadratic equations. The zeros, roots, or x-intercepts, those are the solutions, and it's where the y value equals 0, where the graph crosses the x-axis. The axis of symmetry, x equals negative b over 2a. Welcome to video day 1, unit 11. So today we're going to talk about graphing a quadratic function. So the graph of a quadratic function, day 1. What is the quadratic equation? It's written as y equals ax squared plus bx plus c. This equation has a degree of 2. Now remember that degree is your highest exponent. And then we need a, b, and c to be integer coefficients where a does not equal 0, meaning that this a value can't be a 0 because that would make the x squared no x squareds, which would no longer make it have a degree of 2. So that's why a must not equal 0. The graph of this equation is called a parabola, and it is a U-shaped curve. Parabolas are functions because they pass the vertical line test, meaning that every input has a unique output, or the inputs do not repeat. There are two types of parabola shapes. There's one when the a value is a positive, that will mean the parabola will open up, and where the curve will reach a minimum value. That's whenever the a value is positive. It will look like this, something along those lines. And then the other option is when the a value is negative, meaning that the parabola will open down. This is when the curve will reach a... So when you look at the shapes over here, we can see that, like I said, the a value when it's positive and it opens up, you can see that there's a minimum value here, a smallest point, lowest value. And then when a curve has a negative, it means it has this net down face, this curve opens downward, and that means it has a maximum point. There's a key feature that we need to remember about every quadratic graph or parabola. There's an axis of symmetry on the graph. It is the line of symmetry that can be drawn in the graph to make it perfectly in half. That's the line of symmetry, the axis of symmetry. Now, algebraically, we can also find it using this formula. X equals negative b divided by 2a. So let's look at a couple of examples. We can write an equation for the axis of symmetry for each example below. When we have this graph, we can see that we can find the point where this starts going the opposite direction. So if we look at the parabola, it's going up and then it comes back down. This has a maximum point up top here, and I can see that that means that if I went through that maximum point right here, that would fold my parabola in half on each other. That's the axis of symmetry. So here I can see that that is a vertical line going through the x equals negative 2. And that would be my axis of symmetry. Now in this next example, we have an equation. So I need to find a, b, and c in this equation. Well, really I only need the a and the b value to plug into the axis of symmetry formula. And then I can solve that algebraically without needing to graph. So the a value is negative 1, the b value is 6. I'm going to plug those into the formula. So we have this negative 6, that's the negative b value, divided by 2 times negative 1. Now you can put this in your calculator as a fraction, or you can simplify it. Either way is fine. If you simplify it, you should get a negative 6 in the numerator, a negative 2 in the denominator, and then you can divide them at that point. If you just put them in the calculator, you should get x equals 3 right away. But either way, that is the axis of symmetry for an algebraic example. The next thing we're going to talk about is the turning point. This is either the max or min point in a graph, and it's written x comma y, and it can also be called the vertex. So turning point or vertex mean the exact same thing. How can we find it? Well, to find a turning point, the x and y, algebraically, we would need to first find where that turning point would happen, and that's through the axis of symmetry. Remember how I just went through, when we found that axis of symmetry, it was at that point where it started going the other direction. So finding the axis of symmetry will give me the x value. So to find the x, we're going to use that formula. X equals negative b over 2a, and that's to find the axis of symmetry, which is where the turning point will happen. Then, once we have found that, we're going to sub that value in place of the x in the equation. So I just wrote out, we're going to substitute the x value for the x of symmetry in place of x in the equation. So basically whatever we get up here, this value here will go in place of x in the equation. Then we'll have our point. The x will come from the x of symmetry. The y will be the output when we plug that x value in the equation or the function. The zeros or roots of a graph are the x values where the parabola crosses or touches the x-axis. So to algebraically find the zeros or roots of an equation, those are the x values when the y value equals 0. Remember, that's the same as the f of x equals 0, because f of x is just another way of saying y equals. So that can be found either on a table or algebraically we can find it just like we did in the previous unit. So an example, given the quadratic function graph to the right, identify the turning point. So the turning point is where the parabola starts going the opposite direction. We can see it here at 1, 2. I put a little pink dot there. That's the turning point. And for this graph, that is a maximum point on this graph. And then we can identify the zeros, again, by looking at the graph and seeing where does it cross the x-axis. And I put some points there. We can see that that happens at the x value -1 and then at the x value of 3. So then I just wrote that x is -1 and the x value equals 3, or remember you can write it in set notation. Okay, that's where I'm going to stop for today, and then you will finish up these practice questions as your practice before class, and I'll see you in class tomorrow.